on YouTube and on TikTok. Go ahead and give us some
Hell.
words there, Piezo.
Hey there, can you
All
hear
right,
me?
we can hear you. I think we're good. So what's up?
All right,
What
cool.
shape do you think the Earth is?
Well, I think topographically planar. That's my
Okay.
position. And I actually wanted to see, because I do think that the way that you approach these conversations so far has been generally good, but I don't think anyone has really uh, came in here with any real depth to their arguments.
Facts. I
So
agree.
I kind of wanted to see if we could talk about. I'll let you choose, but I kind of would rather go one way or the other. But I won't tell you which one I would rather. I'll give you the option. But one is a shape claim and one is a motion claim. All right. So my two
We
arguments:
can
one
talk
for
about them. Why
shape.
don't we?
Oh,
I
sorry.
mean, either one's fine. I think that it's probably easier to measure motion without worrying about like refraction and stuff. So why don't we talk about motion?
Motion. Okay.
Hmm.
Sure. So have you ever heard of Airy's failure, George Bedell Airy?
I have, yeah.
Okay. So are you aware of why it's invoked as some kind of proof of non-motion?
I think because you guys think that there's an ether.
Um, well, the motion or non-motion wouldn't be exclusive to a model with or without an ether.
Well, it would, right? Like if there's an ether and the Earth was moving through it and had an ether wind, then Airy should have detected some deviation, but he didn't detect deviation. But that's because there's no ether. You wouldn't like that there would be no ether drag if there's no
O-
ether, so you wouldn't
o-
expect it.
Yeah,
But
but
why don't we
then
actually talk
there
about
wouldn't.
something easier? Why don't we just talk about something that's easier to measure, like the motion, like the Earth's rotation?
You just
Well,
say
actually, we can use that as an argument. It's not hard because the formula that you use and everyone else uses today in a non-etheric model for stellar aberration is simply the tangent angle
you
is the ratio of the two velocities. It's v over c, right? So
Sure.
tangent theta.
So why are we talking about something that's much harder to measure when we could just talk
It's
about
not
the
hard to measure.
rotation of the Earth? Why don't we just talk
He's
about the
trying to
rotation
run
of the
away
Earth?
from this.
Well, do you know? I thought you wanted to talk about Airy.
No, I wanted to talk about the rotation of the Earth.
Well, the rotation is measurable, but it's not necessarily of the Earth or of something else. We know that there's a rotation. The positive claim is
What's
what is
rotating?
rotating,
Oh, hold on.
right?
People can't hear you on YouTube.
So
I don't know. One sec.
instead of getting into a whole host of things like Mickelson,
Hold on. One
they
sec.
can't hear
Oh,
Piazza
I'm
on
stupid.
YouTube.
I'm sorry. One moment.
okay,
Whatever he doesn't want to talk about that, Piazza.
I'm so dumb. I'm sorry. Should be able to see you. It should be good now.
Easier,
Yeah, I can't hear you
check
on
the M
YouTube
if you
too.
can.
Yeah, I think so.
okay. So basically, what I was saying is when you talk about rotation, there's definitely a rotation involved, but it goes to it'll
Okay.
be a lot
What's
longer of a.
rotating?
Well, my position would be that there is an ether wind that is causing a preferred direction in the propagation of light.
So what's actually rotating?
The
And I'm
sky
not
is
talking
rotating.
about propagation of light, by the way. I'm just asking, like, we're not talking about light at
But
all.
but once again, like that'll take us into a whole host of things. MMX, Dayton Miller, Ruyong, Wang, Atsakovsky, Galiev.
No, that's all about the orbit. I'm talking about the rotational motion of the Earth.
No, it's commensurate with or it's involved. It's
Can you
important
can
in
you
talking
account for
about
the
rotation.
can you account for Compton generators or no?
The Compton effect.
The Compton generator.
I'm not sure what a Compton generator is, but
It's a
I think we're
it's a small
bouncing around a
device.
lot.
No, this is about it's a small device that is used to measure the rotation of the Earth about its axis.
No, but just just to be clear, you don't detect ether, you detect velocity
I'm
changes.
not
All these
talking about ether.
arguments, I know,
I'm
but
not
you're
talking
talking
about
about the
so
rotation.
a Compton generator has nothing to do with light, by the way. So the ether, none of this stuff is relevant.
Don't let him get you off track.
What is a
Can
Compton
we just get
generator?
on topic? Like, I
Yeah,
don't
we are. We're
understand.
talking about a Compton generator. We're
Okay,
talking about the rotation of the Earth.
why
We're
is
not
it,
talking about MMX. We're not talking about the orbit of
why
the
is it
Earth. We're
mutually
talking about
exclusive to a rotating Earth?
Well, unless you can produce some account for why fluid starts to spin when
does he
you
sound
flip it
that way?
over, like why it starts to rotate
It's
around some central axis
transitioning.
when you flip it, then
Why it starts to rotate around an axis when you flip
so
it.
I'll explain the experiment. You take a circular tube,
I mean,
fill it with water,
Piezo sounds robotic-y.
you
on
place
the
it on a
screen.
table.
Oh,
let
there
it
you
come
go.
to
I have it
rest,
recorded.
right? Then you just flip it over on its side.
He's trying to change the
So
topic.
you're not flipping it in a way that would
Yep.
induce rotation. You're not like spinning it. You're just
He
flipping it,
knows about
right? But when you do so, the water starts to circulate through the tube, and it circulates in a direction that depends on your latitude. Sorry, it circulates in a direction at a speed that depends on your
Piazza,
latitude.
go back to what you
Do you
know.
have an explanation for this on a flat Earth?
Yep. Don't let him
Oh,
lead you
that's
around.
fun. It would be the same explanation as we use for anything else that has a latitude dependent
Okay,
momentum
what's the explanation?
component. There's
What's
an
the
ether wind,
explanation?
bro. Look, and depending upon
How
where
is-
you are, yeah,
Why
depending
is
on where
ether affecting the motion of water?
it affects the motion of all objects. It does the same thing with pendulums.
Oh, okay. So how does that function?
Because
is the interaction there?
there's a greater velocity at the outer latitude than there is at the inner latitude, which causes a greater momentum at that particular portion of the object, which causes a preferred bias in the rotation.
No, I'm asking what's the interaction? What causes what
Fading
actually, like,
universe,
the ether
Ernst
is a
Mach.
thing in your view. The water is a thing. How does the ether interact with the water?
How does it interact with the water? It's present
Yes.
in all matter. But I mean, I just really wanted to, I came in here to talk about these two things. We can talk
Yeah, we're
about the
talking about the
content
motion of
thing.
the Earth.
Yeah, but you kind of like jumped off of Airy, and
Well, yeah, I don't care about Airy
isn't that
because
completely about the motion of the Earth?
it's not really relevant. Like with Airy, you have to distinguish between ether models and which can be
Well, I was trying to
fairly
explain why I
complicated and
disagree with that.
non-etheric models. But we have mechanisms. We have mechanisms to measuring the shape of or measuring the rotation of the Earth that doesn't rely on light whatsoever.
The sky
Right?
rotates and
So
translates motion to us, like with or without an ether. I believe
why
in
does
one, right?
why does the direction of rotation change whether you're north or south of the equator then?
Why does the direction?
Why does the ether wind spin in a different direction when you're on one side of the equator as opposed to the other side?
Oh, because we live in a toroidal geometry of the ether flow. So like the magnetic field of Earth is a toroidal field. So it causes a flow that follows that geometry.
Tell me what you think a toroidal field is.
What do I mean, do you want to pull up a
Yeah, what do you
diagram of
think
a
it is?
toroid?
Yeah, so
you can model it pretty easy with a dipole magnet. If you use a dipole magnet.
To be clear, you're thinking of a poloidal field, not a toroidal field. Flat earthers tend to get this wrong. The poloidal field is the one that looks like an apple, not a toroidal.
No, like if you take a dipole magnet, it generates a toroidal field.
No, it generates a poloidal field.
We're talking about a hypertrochoid and a toroid commensurate with each other
A
on the outside
toroidal
and
field
inside.
is a toroidal field is
Go
the
back to
magnetic field
Aries.
inside
Back
a
to Aries,
toroidal
bro.
solenoid.
Go back to Battle of the
He
Big
can't. He can't. He has to flow. Stop.
Anyways, so
what's the source of this magnetic field?
the source of it? Not sure. That's immaterial. That we know that we have one. I mean,
how
in
do you
your
know?
model, we can measure it. But once again,
but
is it okay if I
so
describe? I haven't even got to explain what my
position is.
position
in the same direction, north or south of the equator. I know your position is that the Earth is flat.
Yeah, but I'm trying to present information to support my position. I haven't been able to do so because you're kind of scattergunning like 70 questions right now.
I brought up one thing. You wanted to talk about the motion of the Earth, so I brought up a Compton generator, which demonstrates the motion of the Earth.
Is it cool if I give my position for 2 minutes uninterrupted, and then you can
sure if you want, you can read your script if you want. Sure.
Okay, it's not a script, but I appreciate it. Okay, so just to be clear, right? We all agree that stellar aberration exists, right? So since stellar aberration is a true thing, then the claim becomes, what is its cause? Okay, what is the cause of stellar aberration? Now, if you go to Wikipedia or any physics textbook, you can go to the free LibreText online, whichever one you want to use. They will all tell you that it's a product of the ratio of the velocities between the motion of the Earth as it translates itself through space and that of light. Okay, when light enters the telescope, the Earth is said to be moving horizontally underneath it, so that during the time of flight, that it takes the light to move through the telescope, the Earth literally shifts out from underneath the light, which is what causes one to have to tilt it to keep the light centered, the star centered inside the telescope. We agree, and we're all in agreement about that part. That's
That's
not like
roughly right.
Yeah, that's not the controversial part. So where the
We
disagreement
agree that that
lies,
would happen if the Earth was moving, right?
yeah, of course,
Okay. Sure,
of
go ahead.
course. And so then the positive claim, you have a positive claim in your paradigm of motion, right? So you have to have a way to test, right, to test that specific part. So the way that you would do this is you would say, okay, what is the formula to calculate stellar aberration? This 20.5 degrees roughly that we get for about almost every star, how do we get that? It's a
20 and
formula
a
I
half
gave you.
degrees.
Arc
It's not
seconds,
20 and
sorry,
a half
arc
degrees.
seconds,
Okay.
arc seconds. 20 and a
Sure.
half arc seconds. So we have tangent theta equals V over C, or you can use the relativistic formula. Degrees down to like 2/10 millionths of a degree. It's the same. All intents and
Okay,
purposes,
sure.
it's the same. So the only two variables that we have, there's literally only two, are V and C. V is that of Earth, C is that of light moving through the telescope. Well, since we can't change the Earth's speed if it was moving, the only thing that we can change is the velocity of light. So when you put a medium inside your telescope, such as water, for example, it will slow the light down, causing that C component to now be 0.75 C in the case of water. So since the light is moving at 3/4 its original speed, the angle should become
Mhm.
4/3 the original angle. And so,
So now my understanding of Airy's experiment is that they expected a difference after
mhm,
accounting for refraction, which is what you're describing. You're describing refraction. But they didn't detect a difference after accounting for refraction,
mhm. Yeah, so
which
Snell's
means
law,
that they accounted for refraction, i.e. the change in speed of light. That's what refraction
Uh,
is.
well, refraction has a different cause than aberration. Aberration is specifically about the ratio of the velocities. Refraction is about a
Where do you
medium
think that ratio
interface.
comes from?
So let me ask you a question. This is why I believe
Sure.
you're wrong. You're
Okay.
telling me that light entering a stationary bucket of water and light entering a moving bucket of water would be viewed at the same angle through a lens on the other end?
Sorry, one sec. My mouse stopped working. One more time.
If I took a bucket of water and I put a lens on the end of it and I shot a laser through it, right?
Mm-hmm.
Or let's say that I was able to slow the laser down super, super slow so we could see it in like human,
Sure.
human perception, right?
Sure.
You think that shooting it through the bucket with water in it, as the bucket is stationary, and shooting it through the bucket while the bucket is moving would cause the laser to land in the same position on the other end?
Well,
If
you'd
we
have to account for refraction, right?
Sure, but if we represent the laser as a marble that still obeys all the laws of light, just a marble so we can visualize it easily,
But
right?
the thing is it's not a marble, right? Light light is not a marble. It's a wave that is moving at a constant speed in all reference frames. That's the point.
Okay, sure. But
By the way, I
it
have 7 minutes left, just letting you know. So I
okay,
don't
okay.
keep you because I have a meeting.
But
But
for
go
but
ahead.
see, Fuzzo, if you claim it's a wave, we know that Fresnel drag proves that there is a proportional velocity component of a certain percentage of the velocity of a medium in motion that's carried and applied to the light that moves through it. So,
You'd have to be more specific. That was super vague.
Fresnel
Or
drag,
is at least hard to understand what you were saying.
Fresnel drag, okay. He proposed a formula in 1818, I want to say, based on the refractive index of a material being proportional to the compressibility of ether in that material, and he predicted
Sure.
what the speed of light would be moving through a material, and it to this day is actually 100% precisely correct. It was demonstrated in 1851 by Fizeau. He shot two coherent light sources through an interferometer made of water streams. The water's all flowing in the same direction. But then the light takes two different paths through it. So in one path it goes along with the water, and the other path it goes against the water. And he found that the water transmitted 44% of its velocity to the light. So we know
That's
that light
exact wait,
waves.
hold on. That's exactly what's expected under relativity.
They tried to use a relativistic derivation later, but the problem is you can't. I mean, Michelson referred to it even in the Michelson-Morley experiment in 1887. You would have
No,
to
it's
have the
literally derivable from relativity.
No, I get it, but you would have to, in order for that to be, in order for Fresnel drag, right, mechanistically to be accounted for in Airy's experiment, you would literally have to have the wave being carried in the opposite direction of the motion in order to make up for the expected angle change. And that's absolutely preposterous. In page 1 of
So
MMX's
I haven't
original
heard that
paper,
claim. I'm not sure if that's true.
yeah, read 1887 Michelson-Morley's original paper. in
I've
the
read
Michelson-Morley experiment.
Michelson-Morley's original paper.
Page 1, he refers to this, and he refers to how both the ballistic theory of light, like the photon theory, the emission theory,
Mhm.
as well as the undulatory theory, the wave theory, both of them have a problem explaining this, but the emission theory is even worse,
Explaining what?
explaining the results of Airy's experiment.
All right, like we can pull up Michelson-Morley's experiment or Michelson-Morley paper, the 1887 one, yeah.
Yeah.
Page 1.
Yep.
The discovery of the aberration of light was soon followed by an explanation according to the emission theory. The effect was attributed to a simple composition of the velocity of light with the velocity of the Earth in its orbit. That's a mistake. The difficulties in this apparently sufficient explanation were overlooked until an explanation of the undulatory theory of light was proposed. This new explanation was at first almost as simple as the former, but it failed to account for the fact proved by an experiment that the aberration was unchanged when observations were made with a telescope filled with water. For if the tangent of the angle of the aberration is the ratio of the velocity of the Earth to the velocity of light, then, since the latter velocity in water is 3/4 its velocity in vacuum, the aberration is observed with a water telescope. The aberration observed with a water telescope should be 4/3 of its true value. Yeah. So is your claim that they didn't have to account for any refractive effects?
Say that one more time.
Is your claim that they didn't have to account for any refractive effects in the
No.
Airy experiment?
No, that's
Your
not
claim
what I'm
is
saying.
that it lands. Okay, so
Please,
they
please
did have
read
to
the
account for a
footnote.
refractive effect.
Please read
Yeah,
the
yeah.
footnote with the
So
cross.
the footnote says it may be noticed that most writers admit the sufficiency of the explanation according to the emission of light, while in fact the difficulty is even greater than according to the undulatory theory of light. For on the emission theory, the velocity of light must be greater in the water telescope, and therefore the angle of aberration should be less. Hence, in order to reduce it to its true value, we must make the absurd hypothesis the motion of water in the telescope carries a ray of light in the opposite direction. That's fine. Using the emission theory of light, where you assume that the velocity of light is added to the velocity of Earth in its orbit, but that's just not true. Right? That's just a false assumption. So of course, if you make a false assumption that the velocities just add, that light is faster relative to the Earth than it is relative to some stationary ether, then of course you're going to get the wrong answer.
Okay, but see, when
It's just
you
like
look at
trivially not true. Like of course they got it wrong. They didn't know about relativity yet.
relativity doesn't explain it, it predicts the same angle that the classical
Relativity,
formula does.
the claim that you made that according to ether that it wasn't that the emission theory wasn't able to account for Airy's result relies on the assumption that the speed of light varies depending on what reference frame you're in. But if you
Okay,
throw
and
that
it
assumption out
does.
because it's false, it does really. The speed of light varies depending on your reference
Yeah,
frame.
it's
Where's the
slower
experiment?
and
Go win your Nobel
it's
Prize.
hold on. It's slower in. I'll give you two examples. One, I'll explain it, and then two, I'll give
By
you
the
an
way, we're talking
experiment.
about the speed of light in a vacuum, to be clear.
Okay, but check this out. Are you saying in the frame of the water, right? I'm in the frame of the water. If I'm an observer in the frame of the water, when I measure the light in the water, what speed do I measure it as? C or
So
less
you
than
will.
C?
So if you're, I mean, if you're in water, you will measure the light moving at 3/4 the speed of light in a vacuum because that's the refractive index of water.
Okay, so do you know about the Sagnac effect then? Because Sagnac
I do know about the Sinic effect. Yeah.
it literally shows that the speed of light's not constant. It's C plus or minus
It
B.
literally no. That's it. Literally doesn't show that. It shows
It,
that the
it's how all
trajectory
interferometry works.
that a light beam. It literally shows that the trajectory of a light beam in a closed circuit might not or might have a larger space-time interval in one direction than in another direction, depending on the circuit that it's taking.
A
I can
larger
link you.
space-time interval.
I can reference a paper for you if you want, so you can go read about
Sure.
it.
So from the frame, from the frame
Let me see.
of
One sec. Let me pull it up. I have it somewhere. Come on.
how can you have different space-time intervals if you have to maintain Lorentz symmetry on your table?
The space-time intervals are different because the starting and ending points are different. Here's the paper.
So here's a really simple question. Like
Is this the one that I want? Yeah, this is the one that I want.
when you talk about the Sagnac effect, right? We know that what the starting and ending points are. It's the emitter and the detector,
Here,
right?
this paper.
Okay. But the emitter and detector are the start and end points, right? So it starts
Yep.
at the okay. So we'll just use the detector since that's the observer. The detector and the observer are synonymous here. You're an observer, you're a
Sure.
detector, and you're
Sure.
in this inertial reference frame you've established on this table. Now in the lab,
Sure.
of course, the table's rotating, but in the frame of the table, the world's spinning around it, right?
Sure.
Okay. So on the table,
Wait, sorry. Actually, repeat that last statement. I'm not sure I agree.
as an
Yeah,
inertial
I'll
observer
let
on
you
the
have the
table.
last word, but I have to run because I have that meeting that I mentioned 7 minutes ago. So you can have the last word if you want.
Okay. As an inertial observer on the table, you're just stationary on the table. You're the detector, right? You're receiving this light beam from the emitter. It's coming towards you. You see the world spinning around you, right? That's what you see as an observer on the table. With respect to what are you able to measure a friend shift? Because the gap, the length between the emitter and the detector in your frame never change. There's never a change in path length at any moment. There's always a constant distance between the emitter and detector. And so from the frame of the table where the effect is actually measured, there's no way under relativity to derive any type of interference pattern. There shouldn't be a friend shift at all.
I
But it's
suggest
actually
you read this paper. It'll explain how you can derive it using relativity. But I gotta
but
run.
it's
Any
C
final
plus or minus
final
V
words
solves
before I
it.
end it here?
Yeah, in
Any
Saniac's
any last words?
in Saniac's original work, right? He perfectly predicts it and models it using C plus or minus V in the lab frame. Before Prunier redid his experiment and mounted the emitter and detector to a wall, and then put mirrors on a rotating table and spun it and got the same exact result with the mirror and detector, or with the emitter and detector mounted to the wall as they did to the table. It both produced a proportional friend shift to the velocity of the table. So in either frame, in the lab frame or in the table frame, both were shown to be perfectly equivalent, C plus or minus V of the table with respect to the lab, which shows that the lab frame is a preferred frame, aka absolute space.
Okay.
It's a first order timing difference. It's not second order. It's not based on a
I gotta let you
square.
go.
All
I
right.
gotta let you go, but go read this paper. It derives it using relativity. Thanks for being here.
Dude, what a snake. Yo, before I end that recording, before we end that recording, we're going to go over Tartiglia real quick for the boys. All right, let's see. Here's our boy Tartiglia. Hold on, we're going to finish this up.
Dude, with his, how many viewers does he have right now? 600 people listening to him spread lies? They kicked me out. I talked to all those other people, but it had to go real quick, though. Okay.
Dude, you zipped him up really bad. Let's see here. Where's my Tartiglia?
Alan,
Tartiglia.
What paper is he talking about? I wasn't watching.
I got you. I got you. I got you. I've read it.
Good job,
that was
Pietro.
hard to follow. I don't know which audio to listen to or whatever. It was like trying to follow along.
Okay.
My bad.
Now I went straight to TikTok to read those comments.
Nice.
Is there a link to his stream?
Yeah, he was like live streaming on TikTok and YouTube, like a dual cast type of thing. So you could see all the comments scrolling. You could see other people in the comment section getting the lay of the land, seeing what their take on it was. Bunch of nobodies, but still good to see that people were like calling him out on interrupting and not being patient, scattergunning.
All right.
You gonna stream? Oh, I got it. Let me see. I'll check your stream.
Yeah, we're gonna finish out Tartiglia to round out this video, just to make sure he's fully refuted. This paper actually explains absolutely nothing. So, as per Einstein's relativity theory, you're not allowed to use fictitious frames to assign imaginary vectors for electromagnetic processes. You can read that in page 1 and 2 of his 1905 paper. But we're going to skip that and just go through here. So what this paper says, it starts to go over the classical derivation for the Sagnac effect, which shows that C plus or minus V answers the first order timing difference with no transformation. It only requires absolute space for the timing difference to be measured against, so that the clockwise and counterclockwise beams will recombine with a proportional phase difference to the velocity of the rotation and or linear motion, as shown by Ruyang Wang. Now, as we go through the paper here, we're going to see the classical derivation, very nice and clean. Little timing difference is equal to plus or minus the clockwise counterclockwise is going to be equal to 2 VL 2 times the length times velocity over c squared minus v squared, and that's going to give us the when you reduce all that down, you'll get the Sagnac equation, right? So your delta T is going to be 4A times omega over C, which is the basic ratio that everything is all compatible with that's used in modern technology today and was derived by Sagnac in 1913. And also, as shown by Wong in 2004, is compatible with Michelson-Morley's interpretation of how to derive a fringe to show a proportional velocity ratio with the fringe displacement. So these are all accurate. These are all classical equations. They all assume absolute space for the motion to be relative to for there to be a timing difference. Now, what we have here is a cylindrical coordinate system transformation that's going to be invoked as a way for relativity to explain this. What they're going to say here is that if we take this geometrically convenient position at the center of the apparatus, we can watch the non-inertial observer run around us and the speed of light be different for him, and we'll account that as our first order timing difference, because remember, link contraction and time dilation are second order effects. These are going to be a function of the square of the velocity over c squared, which is going to be extremely small. So relativity theory on itself, following the principles, would actually never predict a first order timing difference like this. And this is why you require a fictitious frame and to basically abandon the principles of relativity, which, as stated by Einstein in 1905 on his first and second page, is that the special theory of relativity does not require an ether theory in terms of a fluid medium, or in terms of a mechanism like for propagation, or in terms of a mathematical concept to be used as a preferred frame. Now, that's exactly what this transformation is. We're going to put this, there's no observer in the center here. As Piazio was talking about earlier, we got our source detector and we got our source emitter. These things are equidistant from each other on the apparatus the entire time as they rotate. So there's no relative motion between them under the relativistic theory. Yet there's a first order timing difference shown. So the only way to answer that is to do a invalid transformation that breaks relativity theory. So what we're going to look at here, this is what it would look like if you rolled out that cylindrical coordinate system transformation. We would have the observer here in the center of the device, and this deviation here represents an observer at the rim of the device, which is going to measure the rotational rate because he's in a non-inertial frame, and the speed of light is not constant in a non-inertial frame, even though in that same 1905 paper, Einstein also defined a closed polygonal circuit traveling in uniform transitory motion, i.e. a rotating platform disk, as where his equations would apply. So they actually do apply here. And not only that, there's also Thomas precession, which is facilitated by a, what do they call it? I can't remember the name. Oh, from rapidity, right? So they just establish the deviation angle in between the two frames and correct it so that they can do a linear orthogonal transformation. And there's no difference. And if that's not the case, if that's not true, then there's no explanation for Thomas precession. And then you have to abandon that, or you have to accept that you can apply relativity's equations to a rotating frame. And many people have done so, but under the auspice that there's no contradiction here with the Sagnac effect, and that's never talked about. So anyway, when we get into the space-time coordinate system here, we got our cylinder. Let's see here, and we're going to scroll down to the end. He's going over the different configurations from Wang and such. And what we're going to be looking at here is, where's his last equation at? Yeah, right here. So this is the way that you would do it under relativity using relativistic means with your gamma factor corrections, with your link contraction and time dilation. In other words, to say, to say that the observer in motion is experiencing link contraction and time dilation, which is facilitating the variance in the speed of light. But again, this gamma factor here that I have highlighted is a function of the square of the velocity over c squared, and it's extremely small. So this actually cancels out entirely. And this equation actually, what's that over here? We have a little 2L times velocity over c squared. Anyone recognize that? Anyone recognize that? It's your boy, the classic derivation. Oh, no way. So there is no relativistic explanation for a first order timing difference. That's preposterous. Let's take a look at what it would look like if you tried to derive the Sagnac effect under classical effects and then under relativistic effects using Einstein's actual postulates and adhering to not assigning imaginary vectors where electromagnetic processes once took place, not using a preferred frame. So here my boy's going over the classical derivation, and what we're going to be looking at here is the final reduction for the formalism. It's going to come out to your delta z, which is your change in time. It's going to be 4 times the area of the apparatus, the total, the size of the path, the area of light that it has to travel. That's the path length for the rotation. And then times the angular velocity over c squared. And that's going to give you, I'm sorry, over c times lambda, which is going to give you that first order timing difference right there. Now, what happens when you do it under the paucities of relativity, which state that the speed of light is constant in all reference frames? Well, if the speed of light is constant in all reference frames, then if you had an observer at the source of the light on the rotating platform, he would measure the speed of light being constant, and that light would be shot to a photographic recorder. That would be our other observer. That observer would also measure the speed of light being constant. So when the split beam traverses the closed loop and recombines, there should be no timing difference, at least not in the first order. So what happens is it completes the circuit at the same time, leading to no fringe if you actually follow Einstein's principles. So your delta t would be nothing, because it's going to complete the circuit at the same time. Unless the measurement is made with respect to absolute space, you cannot predict a fringe shift pattern. Now we have this lad here, Post, who specifically points this out in the 60s, and we have Millikins, who makes several attempts to derive the Sagnac effect and co-opt Miller's work as relativistic effects under gravitational equivalences for Miller's work and for... what is it called? For an asymmetrical transformation using a Lorentz transformation for the Sagnac effect, for like a localized Sagnac effect. So by bastardizing the mathematical formalism, that's the only way that you could actually account for the Sagnac effect, and then just, not telling anyone. Does anyone have any questions, comments, or concerns before I end this?
Is there like a 1 or 2 sentence summary as to why that paper was irrelevant?
Yes, that paper is irrelevant. Yes, because link contraction and time dilation are second order effects, meaning they're much, much too small for the effect that's actually measured, and therefore it can't possibly be an effect of link contraction and time dilation. And under specific guidelines from relativity theory, you are not allowed to do the transformation that they're doing to account for a first order timing difference, because there should be none.
Wow.
So just because they throw the gamma factor at the end of their equation there doesn't mean anything, because it can't predict the fringe. So it's going to cancel out. You'll get a value out of it for sure, down to the, unteenth, unmeasurable decimal place. But the first order timing difference, the relevant part of that equation, is what is holding in what actually produces the prediction. And wrap.